The National Flood Insurance Program requires new construction and substantial improvements in designated flood zones to be elevated above the base flood elevation. However, it does not specifically require the relocation of electrical equipment. The FEMA Hazard Mitigation Assistance Grant Program may fund projects to mitigate future flood damage, including the relocation of utilities and electrical equipment out of flood-prone areas. The New Jersey Rehabilitation Code does not explicitly require the relocation of electrical equipment out of flood areas. Municipal building codes may have specific requirements for the installation and location of electrical equipment in flood-prone areas. Check with the local building department for details. Public utility companies may have policies regarding the installation and protection of their equipment in flood-prone areas. Contact the local utility company for information. Several issues should be addressed when a building has flooded. Firstly, electrical cables that were not replaced under the flood level should be replaced to ensure safety and prevent electrical hazards. Secondly, a fire alarm panel placed in a flood-prone area poses a potential safety risk and may not be in compliance with fire code regulations. Thirdly, missing meter tamper seals indicates potential tampering or unauthorized access, which can be a safety hazard. It is recommended to contact a qualified electrician to assess the situation and make repairs or relocations as necessary. Contact the local building department and utility company for guidance on regulations and approvals. Consider relocating the fire alarm panel and other critical electrical equipment out of the flood-prone area to minimize future flood damage. Explore funding options from FEMA or other grant programs to offset the cost of relocating electrical equipment. Electrical systems located in areas prone to flooding present significant safety risks and potential code violations if not properly addressed. Understanding the relevant requirements and recommendations is crucial for ensuring the safety and compliance of electrical installations. Firstly, let's discuss the National Electrical Code, or NEC, which provides comprehensive standards for electrical installations. While the NEC doesn't specifically mandate relocation of electrical equipment from flood zones, it emphasizes protection against physical damage and environmental factors. Article 110.11 addresses deterioration of equipment, stating that equipment must be suitable for the environment. In flood-prone areas, this suggests using equipment rated for submersion or locating equipment above the expected flood level. Secondly, the NEC Article 230.6, which concerns service conductors, requires that these conductors be installed in a manner that protects them from physical damage. This includes protecting them from floodwaters. If service conductors are submerged, they should be inspected and possibly replaced to ensure insulation integrity. Thirdly, NEC Article 312.2 addresses cabinets, cut-out boxes, and meter socket enclosures, stating that they must be protected from the weather and, by implication, from floodwaters. If these enclosures have been submerged, they need to be assessed for corrosion and structural integrity. Replacement may be necessary. Fourthly, let's discuss ground fault circuit interrupters, or GFCIs. The NEC requires GFCI protection in readily accessible locations that are at or below grade level, where there is likely to be standing water. This requirement extends to circuits serving equipment in flood-prone areas to protect against electrical shock hazards. Fifthly, consider the impacts of floodwaters on wiring methods. The NEC specifies various wiring methods such as non-metallic sheathed cable, or NM cable, and electrical metallic tubing, or EMT. NM cable is generally not suitable for wet locations or submersion, while EMT offers better protection but may corrode if submerged. In flood-prone areas, consider using wiring methods like liquid-tight flexible metal conduit, or LFMC, with appropriately rated conductors. Sixthly, let's discuss equipment elevation. While the NEC doesn't explicitly require relocating equipment above the base flood elevation, or BFE, it is a prudent measure to protect electrical systems from flood damage. Elevating service equipment, distribution panels, and other critical components can significantly reduce the risk of water damage and electrical hazards. Seventhly, consider local amendments and interpretations. Local jurisdictions often amend the NEC to address specific environmental conditions, including flood risks. Check with the local building department to determine if there are any local amendments or interpretations that apply to electrical installations in flood-prone areas. Eighthly, let's discuss the importance of professional assessment. After a flood event, it is crucial to have a qualified electrician assess the electrical system for damage and safety hazards. A thorough inspection can identify damaged components, wiring issues, and potential shock hazards that may not be immediately apparent. Ninthly, consider the role of insurance requirements. Insurance companies may have specific requirements for electrical installations in flood-prone areas. Compliance with these requirements may be necessary to obtain or maintain insurance coverage. Tenthly, let's discuss the ongoing maintenance and inspection. Electrical systems in flood-prone areas should be regularly inspected and maintained to ensure continued safety and reliability. This includes checking for corrosion, loose connections, and other signs of deterioration. 11thly, consider using flood-resistant materials. When replacing or installing electrical equipment in flood-prone areas, consider using flood-resistant materials such as stainless steel enclosures and waterproof connectors. These materials can provide added protection against water damage and corrosion. 12thly, let's discuss surge protection. Floodwaters can damage electrical equipment and increase the risk of power surges. Installing surge protective devices, or SPDs, can help protect sensitive electronic equipment from voltage spikes caused by lightning or other electrical disturbances. 13thly, consider backup power systems. In areas prone to frequent flooding, consider installing a backup power system, such as a generator or battery backup, to ensure continued operation of essential equipment during power outages. 14thly, let's discuss emergency procedures. Develop and implement emergency procedures for shutting down electrical equipment in the event of a flood. This can help prevent electrical hazards and minimize damage to the system. 15thly, consider the use of submersible pumps. If flooding is a recurring issue, install submersible pumps with appropriate GFCI protection to remove water from the affected area quickly and safely. 16thly, let's discuss sealing penetrations. Seal all penetrations in walls and floors to prevent water from entering the building. Use waterproof sealant and appropriate sealing methods to ensure a watertight barrier. 17thly, consider the impact of floodwaters on grounding systems. Floodwaters can affect the integrity of grounding systems, potentially increasing the risk of electrical shock hazards. Inspect and test grounding systems after a flood event to ensure they are functioning properly. 18thly, consider the use of elevated wiring methods. When installing wiring in flood-prone areas, use elevated wiring methods such as running conduit along walls or ceilings to keep wiring out of the path of floodwaters. 19thly, let's discuss the importance of documentation. Maintain accurate records of all electrical installations, inspections, and repairs. This documentation can be valuable for insurance claims and future maintenance. 20thly, consider the impact of floodwaters on electrical equipment labels and markings. Floodwaters can damage or remove labels and markings on electrical equipment, making it difficult to identify components and their ratings. Replace any damaged or missing labels and markings to ensure proper identification and operation. 21st, let's discuss the impact of floodwaters on electrical panels. Floodwaters can cause corrosion, damage to internal components, and compromise the integrity of electrical panels. Panels that have been submerged should be inspected and potentially replaced to ensure safety and reliability. 22nd, consider the use of waterproof enclosures. When installing electrical equipment in flood-prone areas, use waterproof enclosures to protect components from water damage. These enclosures are designed to withstand submersion and prevent water from entering the enclosure. 23rd, let's discuss the impact of floodwaters on electrical motors. Floodwaters can damage electrical motors, causing corrosion, insulation breakdown, and mechanical failure. Motors that have been submerged should be inspected and potentially rebuilt or replaced to ensure proper operation. 24th, consider the use of flood vents. Install flood vents and foundation walls to allow floodwaters to enter and exit the building, reducing hydrostatic pressure and minimizing structural damage. 25th, let's discuss the impact of floodwaters on lighting fixtures. Floodwaters can damage lighting fixtures, causing corrosion, bulb failure, and electrical hazards. Fixtures that have been submerged should be inspected and potentially replaced to ensure safe and reliable operation. 26. Consider the use of elevated outlets and switches. Install outlets and switches at a higher level to keep them out of the path of floodwaters. This can reduce the risk of electrical shock hazards and minimize damage to the electrical system. 27th, let's discuss the impact of floodwaters on smoke detectors and carbon monoxide detectors. Floodwaters can damage smoke detectors and carbon monoxide detectors, rendering them ineffective. Replace any detectors that have been submerged to ensure continued protection against fire and carbon monoxide hazards. 28th, consider the use of waterproof connectors and fittings. When making electrical connections in flood-prone areas, use waterproof connectors and fittings to prevent water from entering the connection and causing corrosion or electrical faults. 29th, let's discuss the impact of floodwaters on electrical appliances. Floodwaters can damage electrical appliances, causing corrosion, insulation breakdown, and mechanical failure. Appliances that have been submerged should be inspected and potentially repaired or replaced to ensure safe and reliable operation. 30th, consider the use of elevated electrical meters. Install electrical meters at a higher level to keep them out of the path of floodwaters. This can reduce the risk of water damage and ensure accurate meter readings. 31st, let's discuss the impact of floodwaters on communication systems. Floodwaters can damage communication systems such as telephone lines and data cables, disrupting communication services. Protect communication systems from flood damage by using waterproof connectors and elevated wiring methods. 32nd, consider the use of flood barriers. Install flood barriers around critical electrical equipment to protect it from floodwaters. Flood barriers can be constructed from a variety of materials such as concrete, steel, or inflatable barriers. 33rd, let's discuss the impact of floodwaters on renewable energy systems. Floodwaters can damage renewable energy systems such as solar panels and wind turbines, causing corrosion, electrical faults, and mechanical failure. Protect renewable energy systems from flood damage by elevating equipment and using waterproof connectors. 34th, consider the use of smart home technology. Use smart home technology to monitor and control electrical equipment in flood-prone areas. Smart home systems can provide alerts when water is detected and automatically shut down electrical equipment to prevent damage. 35th, let's discuss the impact of floodwaters on data centers. Floodwaters can severely damage data centers, causing data loss, equipment damage, and service disruptions. Protect data centers from flood damage by elevating equipment, using waterproof enclosures, and implementing flood control measures. 36th, consider the use of uninterruptible power supplies, or UPSs. Use UPS to provide backup power to critical electrical equipment during power outages caused by flooding. UPS can ensure continued operation of essential systems and prevent data loss. 37th, let's discuss the importance of public awareness. Educate the public about the risks of electrical hazards in flood-prone areas and promote safe practices for using electricity during and after a flood. 38th, consider the use of flood insurance. Obtain flood insurance to protect your property from flood damage, including damage to electrical systems. Flood insurance can help cover the cost of repairs and replacements. 39th, let's discuss the importance of community planning. Participate in community planning efforts to address flood risks and develop strategies for mitigating flood damage. Community planning can help protect the entire community from the impacts of flooding. 40th, let's discuss the importance of staying informed. Stay informed about flood risks and weather forecasts in your area. This will help you prepare for potential flooding events and take necessary precautions to protect your property and electrical systems. Always prioritize safety when dealing with electrical systems in flood-prone areas. If you are unsure about the safety of your electrical system, contact a qualified electrician for assistance.